The reason that we know that reality is indeterministic is that we can prove that reality is continuous. And on that basis, we can prove that reality is indeterministic. So let's begin by proving that reality is continuous. Please keep in mind, by the way, that the full detail of these arguments is given in my book, and I'm presenting just the main ideas here. It's easy to prove that reality is continuous because if we assume the opposite, then reality can be represented by the integers. So suppose that we have a square having sides of integer length 2. The sides are shown as large dots because we're assuming that there are only integers, so there are no numbers of any kind between 1 and 2. What is the length of the diagonal? It's 2 times the square root of 2. The number 2 times the square root of 2 is not an integer, thereby proving that the integers are insufficient to represent reality. This result that we've proven in two-dimensional space obviously generalizes to three-dimensional space, and it generalizes from there to four-dimensional space-time, where time is the fourth dimension. Thus space is continuous, time is continuous, and space-time is continuous. I now wish to introduce a principle that I refer to as the knowability principle. The knowability principle says that reality, the totality of what exists, is limited to what is logically knowable. This is easy to see by assuming that something exists that is logically unknowable to us. Since this thing is logically unknowable to us, it can't affect our observations in any way, now or in the future, on Earth or in afterlife. As a result, it is non-existent with respect to our life. If you believe in God, notice that something that is logically unknowable to us is also logically unknowable to God. For if it were logically knowable to God, then God could tell us about it, even if we could not completely understand it, as in our learning about Einstein's relativity theory, without completely understanding. It follows that reality is limited to what is logically knowable. Thus far, we've proven that space-time is continuous, and that we've established that reality is limited to what is logically knowable. I also wish to note that the ancient theorist Plato was dissatisfied with the idea that existence is limited to space-time experience, so he assumed an abstract, ideal, unchanging realm of existence that lies outside of space and time. Christians later incorporated this idea by claiming that God has an abstract, ideal, unchanging existence that lies outside of space and time. But such a notion can't be rationally defined, so it is not part of a rational model of reality. So reality is limited to what is logically knowable, and reality is continuous. Now we will see that, since reality is continuous, it is also indeterministic. Let's begin by asking what it means for reality to be deterministic. I invite you to pause the video on the next slide and answer the question. There are two facets of determinism: deterministic states and deterministic order. Determinism is a relation between two states of reality, whereby one state occurs before the other state occurs, and given that the first state occurs, it is logically necessary that the second state occur. But in order for this to have meaning, the states must be deterministic. That is, the states must be discretely, non-probabilistically defined. Hence, determinism entails deterministic states that occur according to a deterministic order. We will now see why the idea of deterministic states is irrational, thereby implying that determinism is irrational. But for completeness, I wish to mention that in my book I also prove that the idea of deterministic order is irrational. The proof of indeterministic states follows from the fact that reality is continuous. To see what this entails, let's consider the number line. In order to specify a point, we refer to a number. But because reality is continuous, we must specify an infinite number of digits for each number in order to distinguish the number from all of its neighbors. This is obvious for the square root of 2 because the decimal expansion of the square root of 2 is non-repeating. However, it is also true for a number having a repeating decimal expansion, such as 0, because 0 here is not an integer, but is a point on a continuum. And the same applies to the other integers as well. Now that we understand what a continuum entails, we can see that it is logically impossible to observe a point on a continuum because a point on a continuum has infinite precision, while an observation of measurement has only finite precision. To observe a point on a continuum would take an infinite amount of time in order to obtain infinite measurement precision, so it could never be achieved. This conclusion is corroborated by probability theory, which says that the probability of observing a point on a continuum is 0. Since a point on a continuum can't be observed, an interval on a continuum, such as the interval from 0 to 1, can't be observed as a discrete interval, since it is bounded by points which can't be observed. If we can't observe a point on a continuum, and we can't observe an interval on a continuum, then what can we observe? What we are left to observe is a probability distribution. More precisely, we are left to observe a portion of reality that can't be characterized discretely, but can be characterized only by a probability distribution. Furthermore, just as it would take us an infinite amount of time to observe a point on a continuum, so it would take reality an infinite amount of time to create such a point. If points don't exist, then discrete intervals don't exist either. But if points don't exist and if discrete intervals don't exist, what does exist? All that exists is reality, which of logical necessity must be characterized in terms of probability distributions. In conclusion, our knowledge of any state of reality is necessarily probabilistic because reality is continuous. We recall that the knowability principle says that reality is limited to what is logically knowable. It follows that we have proven that any state of reality is probabilistic or indeterministic, thereby implying that reality is indeterministic. In Part 2, we'll consider a few examples along with a few ramifications of this result.